Okay, here we are, the next question. Give it a moment here to get the stream and the audio going. Clumsy Factorial on LeetCode 2006. Let's see, hello, hello, hello. 2006. Let's see, hello, hello, hello. Very good. All right, so now what I want is 1006. Let's top right. Refresh here. Okay. What I want to do is try this question. Oh wow, it's exactly 50-50 here, huh? Yeah. All right. The factorial of a factorial of a positive integer n is the product of all positive integers less than or equal to n. Factorial of 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We make a clumsy factorial using the integers in decreasing order by swapping out the multiply operations for a fixed rotation of operations with multiply, divide, add, subtract, and subtract in this order. For example, clumsy, 10 times 9 divided by 8 plus 7 minus 6 times 5 divided by 4 plus 3 minus 2 times 1. Okay. However, these operations are still applied using the usual order of operations of arithmetic. Do all multiplication and division steps before any addition or subtraction steps, and multiplication and division steps are processed left to right. So we do multiply, then divide, then add, then subtract, then multiply, then divide, then add, then subtract. Okay. Additionally, the division that we use is the floor division, such that 10 times 9 divided by 8 is equal to 90 divided by 8, which is 11. Give an integer n, return the clumsy factorial of n. Okay, that's an interesting question. And n is 10,000. This shouldn't be too challenging. The problem you run into is before doing the additions and subtractions, you'd want to pre-process all of the multiplications and divisions. So yeah, you can kind of add 7. You can multiply and divide, then add 7, then push that onto to a stack of what you're going to subtract next. And then it's going to be 6 times 5 divided by 4 plus 3. Push that onto a stack. What you're going to subtract next again. And then perform all the subtractions. Yeah. It's actually, the additions and subtractions can be kind of, the first value, I guess these. Excuse me. Yeah, I'm not so sure about this one. I think it's not so obvious what I would do here. I suppose I would try, the first value is going to be added, and then we add 7 to that, and then we're going to subtract the next value, and then add 3, and then subtract this next value. I think how to do this. I don't know. I'm not sure. I think you could do this in linear time, by the way. Maybe using the stack. Not really obvious how to do this. You think? I'm trying to decide whether it's, whether it's easier to try to compute this like in a more direct way, or if it's better to just try to like use basically write like a relatively simple calculator program and then just run this through the calculator, kind of a thing. Like just make a big string out of this and then run it through that. I don't know if that's a good idea. Well, okay, what would the direct approach look like? Probably the first term you would add, and that first term is combined 10 times 9 divided by 8, right? And then addition, right? So you'd add 10 times 9 divided by 8 plus 7. And then finally, subtraction needs to be kind of put onto a stack, I suppose. Yeah. The addition can be performed immediately. The subtraction, we know that there's going to be multiplication and division afterwards, and those need to be processed first. I mean, you can also just have a sign of each term, and then just say, you know, when you see a plus sign, you can just add what comes next. If you see a negative value, then you're going to create something after that and subtract it. Yeah, the additions can be added directly to the result. This is subtractions, you just need to wait to process the multiplication and division. I don't really know. I don't know how exactly I want to do this. Like maybe some kind of like state machine type of thing. I'm not too sure. Let's try something. I don't know. Trying to think about this here. So the result starts off at 0. Let's say n, right? And we would say op starts off at goes 0, 1, 2, 3, right? 0, 1, 2, 3. And we'll just say enum op is just multiply, divide, add, subtract. Can I do it that way? Yeah, I mean, yeah. And we're going to update the op to the next one, right? Modulo 4. I mean, I don't know. Maybe I could just do it this way. I'm not sure. I don't know. I have a switch statement for the operation. All right. So we have multiply, divide, add, subtract. Switch on the operation. Turn the result. So for multiply, we have sort of a current value. Current multiply equal n. Divide equals n. And then add is going to be result plus equals n. Subtract is so what's interesting about this is that I would want to take the current value before the subtraction and add it, right? I don't know, it's so confusing. I don't know how to handle that. I don't know. I'm not sure. No, I don't know. I don't have to really think about it. Because I want to add the first value for current, right? So when I see a when I finish or when I see a subtraction, right? That's when I'm going to take the result and I'm going to add to it the current value, right? And it's going to be toggle, right? So we'll have sub is false. So if subtraction is true, then we're going to make this negative. So the way this is going to work is if subtraction is true, we're going to turn it to a 2. 1 minus 2 is negative 1. We're going to subtract the current value if sub is true. Initially, sub will be false. But once we reach subtract, we're going to set sub to true, right? The addition part, we do that independently. Over here as well, we can add same thing, 1 minus sub 1 times current. Add that at the end as well. And here we would set current to back to 1. Really should be 0 actually. If current should be equal to n when you multiply. That just starts it off that way. Yeah, that's probably the way to do it actually. This is confusing, I realize, but something like this I think works. Hopefully that compiles. Oh, it does compile. Okay, cool. We got 3, 4, 7, 10, 10, 3, 12. Okay. All right. So let's just walk through this. When n is 4, we have op is 0. We multiply. Current is 4. Then we go to the next operation. Current is now 3. Operation should be divide. We divide 4 divided by 3 is 1. We go to the next operation, which should be add. N is now 2. We add 2. So 4 divided by 3 is 1 plus 2. And then finally, we have the last operation. 1 with subtract is subtract 1. So now we're going to add to this result the 1 that we had, right? We set sub to true here. Sub is not true before. So this is just we add 1. Current gets set back to 0. So now we're at 3 for the result. Current is 0. Subtraction is true. And then at the end, we're going to set 1 minus sub times current. This actually should start off at n, not... yeah, that's kind of interesting. So actually, multiply is the next value. Excuse me. I did this wrong, huh? Multiply, I don't think does anything. Current starts off at n. When you multiply, current is already n when you multiply. So it doesn't really do anything. When you divide, you can now divide n. It's actually... It's actually slightly incorrect. It's more like n minus 1 that you divide by. Yeah, you're not actually multiplying by... This really should start off at subtract, actually. And then this is, but the sub is false. That's so confusing. So the initial operator is a subtract operator. Yeah, but it doesn't. That is so confusing. You actually should start off at n-1, really, I think. Very confusing. Excuse me. So we start off with n, and now the operation is multiply. To multiply, we don't do anything with n. We just leave it as it is. Now the next operation is divide, and n is now the value to the right. And we do that, that's fine. Then we add that value to the right, we add it. Now subtracting, we're going to take that result, we're going to set up sub, and we're going to take that value to the right and set that to current. It's something like this is more of what we want, what I want. It's definitely not obvious how to do this. And this 4 output is 3. So how does this work on 4? So 4 comes in, operations multiply, we decrement n. Now it's at 3. We don't multiply at all. We divide 4 by 2, which is not correct. N should not actually be decremented here. Here n is 4. Operations multiply. We don't do anything, we just skip. Then we go to 3. Operations divide. This is correct now. Divide by 3. Then we add 2. And then when we subtract 1, we add the 4 divided by 3, which is 1, so we end up with 3. And we set n to 1, or current to 1, with sub to true. And then at the end, we would process that and subtract the current value, which is 1. And so I think we expected 7. I don't know where we got 7 from. How do we get 7? What is going on? Is it wait. Oh. What? 4 times 3? Wait a second. Oh. Oh. Whoops. Oh, I see. Oh. Okay. Excuse me. Yeah, so actually should decrement n. What? I loosened my mind here, I don't know. I didn't understand it, I think. Let's just try a bunch of different cases. I think I need to take each modulo. Just do 1, 2, 3, 4, and 5. So it took me a while, I think, to get through it. How are we doing here? 19 minutes? I think that's it. It's just, yeah, try to do it kind of directly. A little bit complicated. Those are the first 5. Yeah, I mean, it's just, okay, those are the first 5. Let's go 6, 7, 8, 9, and 10. 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to go all the way up to, I want to go through a few rotations of things. Okay, 13, let's go all the way up to 14, 15, 16, 17, 18, 19, 20, 21. a little easier to put in test cases this way. All right, and then try to go for some random things. So like 100 and 200 and 1,000 and 1,500 and some random numbers and 999 and 10,000 we did already. Do I don't know, 998 and some gibberish, not gibberish but random stuff. Okay, I think I got it. Gonna go for it. Yeah, it's not easy to prove that's correct. Not the easiest thing to prove that's correct, but that seems to be. There we go. Got it. Okay, that's that was an interesting one. All right, I'm going to submit this 4 more times, and then we'll go to the next thing. Interesting question. I don't know, it took 20 minutes or so. It took some time. It's going fast, which is good. It's 100% every time. 3. Let's do 1, 2, 3, 4, 5. The next question is going to be minimum domino rotations for equal, whatever it is, 1, 2, 3, 4, and one more time. The 5th one. Yeah, so doing this directly I think is not bad, or trying to do it directly is fine. 1, 2, 3, 4, 5. All right, fine. On to the next one. So what I'm going to do now is stop the stream. If you like the video, don't forget to like it and follow the stream for more. I'll stop here, and I'm going to start another stream with a different title to go to the next question.